Dear students, today we are going to start a Unit 2 Explainable AI. So please listen carefully. This concept is very important for your examinations and also for the real world AI system. This is a very important topic. Okay. So our topic is today anti-hoc explainability models. Okay. Before going deep, tell me one thing. If an AI system give a decision, should we blindly accept it? Should we blindly accept it? No, right? So we must understand how the AI system think. Okay, so that is exactly why explainable AI is introduced. Okay, okay, students, are you able to follow this idea? Have you got it? Good. Can we move the next slide? So, what is anti-hoc explainability? Which means the meaning of anti-hoc. Okay, students. Now, let us understand the word anti-hoc. So, anti-hoc means before the fact. So, that means the explanation is already built into the model itself. The explanation is already built into the model itself. Right? While the model is working, it is also explaining in the decision. While the model is working, it is also explaining the decision. So we don't need to ask later, why did you predict this? So the model itself shows this reason. Have you understood what does anti-hoc means? The anti-hoc meaning before the fact, which means the explanation is already built into the model itself. The simple student analogy. Now I will give you a very simple example. Think of two students writing an exam. One student write all the steps clearly and the another student write only the final answer. Which answer will teacher trust more? Obviously, the one who shows the step. Okay, so the same like that, the anti-hoc model are like the student who shows every step. The post-hoc model explain only when we ask later. Have you got it? The anti-hoc model or like the student who shows every step. The post-hoc models explain only we ask later. Okay. Have you got this analogy? Very simple, right? So now see this comparison of the table carefully. Okay, don't rush. This is the important for your examination. So anti-hoc explanation happens during the model design. Okay, anti-hoc explanation happen during the model design. The post-hoc explanation happens after the prediction. So the anti-hoc explanation happens during the model design. The post-hoc explanation happens after production. So the anti-hoc models are very transparent. Okay. The post-hoc models are black box. For example, decision tree, linear regression, that is undercome the anti-hoc. Line, sharp, that is undercome the post-hoc. So can you see the difference clearly now? Yes, good. Hope you understood. We will move the next slide. The characteristics of main characteristic. Okay, students. Now let us see the main characteristics. First point, the model structure itself is interpretable. Okay, the second one is the parameters have the direct meaning. So every prediction can be traced via specific rules or features. That is why these models support the fairness and accountability. Okay, students, if something goes wrong, can we debug easily? Yes, exactly. Okay, if something goes wrong, can we debug easily? Okay, So have you understood the point? So for example, linear regression shows how many each input contributes. Okay, va? Properties of anti-hoc models. Okay, the first one, advantages. Instead of we have to saying that advantage of explained slowly. Now, okay, students. Now the advantages. First, simplicity. Okay, so you can easily draw and understand the model. Okay, which mean easy to visualize and understand. The second one is transparency. So nothing is hidden inside, which means all the computations are open and clear. The third one is fidelity. So the explanation exactly match the model behavior. Okay, so explanation exactly match the model behavior. The fourth one is actionable explanations. So users can improve their input. Okay, users can improve their input. They increase the score and reduce the risk too. So are you able to relate to the real life? Simplicity, transparency, fidelity, consistency, actionability. Okay, so these models don't hide anything. You can literally follow the path from input to output like a decision flow chart. Okay, now listen carefully. There are the important types of anti-hoc models. So the first one is decision trees. The second one is linear regressions or logistic regressions. The third one is rule-based models. The fourth one is generalized additive models. So the first one, decision tree, is each node equal to decision rule. Okay, which means the entire tree path from root to leaf. Okay, it's a reasoning chain. For example, if income less than 5 lakhs, na credit score less than 700, so credit score greater than 700 and the income greater than 5 lakhs, the loan may be approved. So the each node to have to take a decision. The second one is linear regression or logistic regression. So linear regression or logistic regression mainly show the importance of direction of each variable. Okay. Then rule based model. So the rule based model is mainly purpose for the human readable if then rules. So if fever equal to true and a cough equal to true, finally we get the output flu. And the final one is generalized addictive models. So it combined the simplicity of linear models with the flexibility of non-linear terms. So it allowed the plotting of each feature's effects separately. So all these models are naturally explainable. So okay student, just remember if the model itself is understandable, that is called as anti-hoc. Clear? So now see the decision tree. So each node in the decision tree, okay, sorry, each node is a decision, each branch is a condition, and each leaf is the final output. So from root to leaf, we can trace the full of reasoning. So for example, if income is high and the credit score is good, the loan will be approved. If the income is high, the credit score will be good, the loan may be approved. Okay. So, okay students, can you see how clearly the reasoning is shown? Yes, that's why the decision trees are very popular. Can we move the next slide? Linear regressions. So now look at to the equations carefully. What is the equations here? Risk equal to 0.45 age of minus 0.30 exercise plus 0.60 BMI plus 2.1. Okay, which mean the age increases risk, exercise reduces risk, BMI increases, risk more. Okay, so the model is not hiding anything. So we can read the prediction like a sentences. Okay, so okay students, have you understood how coefficients explain the behavior? Okay, so what are the coefficients here? Age increases, risk. Exercise reduces, risk. BMI increases, risk more. So how the coefficient explain the behavior? Okay, the next one, the rule-based model. Now, students, for example, now a medical example. Okay, I will take an example of medical. If you have fever and a cough, maybe flu. Okay, if you are rash and itching, maybe the allergy. So, very simple. If, then rule. If, then rule. Okay, so doctors can immediately say doctors can immediately say whether it makes a sense or not. Okay, so do you feel this is easy to understand? Okay, that is the strength of rule based if then rules. The next one is generalized addictive model. Okay, GAM. So GAM means generalized addictive model. So it is like a linear regression. Okay, but more flexible compared than the linear regressions. So it is look like exactly linear regression but more flexible. So each feature has its own function. Okay, each feature has its own function. So we can plot and see the effect separately. We can plot and see the effect is separately. So the GAM is bend a little but don't break interpretability. Okay, bend a little but don't break interpretability. Okay, it is a nice concept. The next one, advantages of anti-hoc models. Okay, now let us recap our advantages as I already told that. The first one is naturally explainable. Okay, the first one is naturally explainable. The second one is the easy for regulated industries. Easy for regulated industry. The industry may be finance, healthcare, medical. Okay, so then third one is less hidden bias. Less hidden bias. Fourth one is easy auditing. So for example, the bank can explain the loan approval clearly. Okay, if the income above the 5 lakh, if the credit score above the 700, you will get a loan approval. If it is not, maybe doubted. If it is below to the criteria, the loan will be rejected completely. Okay. So have you understood why government prefer this model, anti-hoc models? Okay, but no model is perfect. No, no model on is perfect. So anti-hoc models may give the lower accuracy for the complex data. The first one is lower accuracy for the complex data. And then the second one is they can't handle the images on the text well, on the text well. So they may not change scale for the huge data. So there is a trade-off between the simplicity and the performance. Note that word. There is a trade-off between the simplicity and the performance. Okay. So have you clear about these limitations? Okay, in the real-time applications use cases. Okay, now the applications are banking. First one is important industry banking. So the credit score using the logistic regression. Okay, so credit score using the logistic regressions. The healthcare. So the risk prediction using the GAM rule. Okay, GAM or decision, the risk prediction. And the third one is law and policy. So the law and policy may be using the transparent decision making models for fairness. Okay, at the fourth one is education. That is an important industry, important sector. The student performance prediction using the explainable regression. For example, the loan approval decision. Okay, the easily explained with the T path are the featured weights. Okay, have you got it? That are the many industries I have used. In the important industries are banking, healthcare, law and policy, education. Okay. In all cases, explanation is very, very, very important. Why it is rejected, why it is approved, like that. Okay. Okay, students. So finally, the future. Researchers are combining the deep learning with the explainability. So hybrid and glass box AI models are coming. So the future is not just accuracy. It is the accuracy with the explanation. Note that word, the accuracy with the explanation. Okay, students, have you understood today's topic clearly? If yes, that's a great. Okay, we will continue the next class. Okay, thank you.